Now I am going to explain about electric dipole is placed in a uniform electric field. How much amount of torque will be produced? Okay. Now the torque acting on an electric dipole placed in a uniform electric field. What is meant by an electric dipole? Means already you know. What is meant by a uniform electric field? We explained about the flux. That means all the electric lines of force which are parallel to each other and separated by equidistance, then that is called what? Uniform electric field. Okay. Now that electric dipole is placed in a uniform electric field. Okay. Now what happens? It is making an angle theta here. Okay. This theta same. Now draw a perpendicular. This is A, this is B, this is the center. Okay, P. Okay, draw a perpendicular here. This is 2A or not? This is 2A. Then what is this one? ABC from the triangle. Sin theta how much? BC by AB. BC how much? BC we don't know. BC equal to how much? AB sin theta. AB is how much? 2A. So you will get 2A sin theta. 2A sin theta. Now what is the torque? Torque is defined as the product of force and perpendicular distance. Now in this charge the force is acting like this, EQ. This is minus EQ. On this charge the force is acting like this, EQ. Both forces are in opposite direction and having magnitude same or not. That means that the resultant force is 0 because equal and opposite. Magnitude of force is EQ and perpendicular distance is 2A sin theta. 2A sin theta. You know 2AQ is nothing but P E sin theta. Now it is a vector, so the torque is the vector product. Tau bar is equal to P bar cross E bar. That means if theta is equal to 0 or 180, then there is no torque present in the dipole. If theta is equal to 90, then tau is maximum. That maximum torque is represented as P. Okay, that is about the torque. Now what is the amount of work done in rotating an electric dipole from theta 1 to theta 2. I want to rotate this electric dipole from this position to this position. Okay, this is the initial position. Now this position is changed like this. That means initially the dipole is making an angle theta here. Now I am considering a small angle like this, theta. So initially theta is present. Now finally total angle is theta plus d theta. So to do from this position to this position, you should do some work or not. That small work is represented by dw. dw. We know that work is the product of force and displacement in translatory motion. In rotatory motion, product of torque and angular displacement. Okay. Now what is the torque produced here? Tau equal to P sin theta. P sin theta d theta. Now to get the total work, integrate on both sides. Integral dw is equal to integral P sin theta d theta. What is integral sin theta d theta? Instead of sin theta, integration gives minus cos theta. Minus cos theta. So this is the total work. That means minus PE cos theta is the total work done. Okay. Now, if it is making an angle from theta 1 to theta 2, theta 1 to theta 2, thus work done is equal to PE. Here integration limit should be applied. Then you can write like this: cos theta 1 minus cos theta 2. If theta 1 is equal to 0 and theta 2 equal to theta, then W equal to PE into 1 minus cos theta. If theta 1 equal to 0 and theta 2 is equal to 180, then W is equal to PE into 2 PE. If theta equal to 0 and theta 2 is 90, theta 1 0, theta 2 90, then you will get only PE. That is about the work done. Okay. Please subscribe my channel Sri Sai Physics for Mains and NEET, and who are studying this second year or first year can subscribe, and you can view this channel. Okay. Please share it. Thank you for watching.